Hello viewers, welcome to Senior College Mathematics. Topic of discussion is angles of elevation and depression. Lesson 4, Selected Problems, Part 3. Example 8. From a horizontal distance of 8.5 kilometers, a pilot observes that the angles of depression of the top and base of a control tower are 30 degrees and 33 degrees respectively. Calculate correct to 3SF. Roman figure 1. The shortest distance between the pilot and the base of the control tower. Roman figure 2. The height of the control tower. Solution. The control tower is a building that can be rectangular or square in nature, and the pilot is above the control tower. So let us take this as the control tower. This is the control tower. Okay, the pilot is above the control tower. This is the eye level, the pilot. The pilot looking at top of the control tower. The angle of depression is 30 degrees. Then looking at the base of the control tower, the angle of depression is 33 degrees. So this angle, 30 degrees, equal to this angle. And this angle 33 degrees is also equal to this angle. The horizontal distance is 8.5 kilometers. The shortest distance between the pilot and the base of the control tower is from where the pilot is to the base of the control tower. So let's have the complete diagram with proper labeling to enable us continue with the solution. The solution continues. I've already explained the diagram. ST is the tower. The pilot is somewhere here. So from here to the top, the angle of depression is 30. Then to the base, the angle of depression is 33. So here becomes 30 angle of elevation equal angle of depression. Here is 33. The shortest distance is PT. To get PT, we have to consider triangle PROT. PROT. Looking at this angle, the distance here is 8.5. Then looking at this angle now, this is opposite. You have adjacent and hypotenuse. We are interested in hypotenuse. It must be cosine. So cos 3 degrees equal to ROT adjacent over hypotenuse PT. You have it in this form. Multiply through by PT to clear fraction. You have this result, and PT is equal to 8.5 over cos 33. You have it in this form. After division, you have 10.134 kilometers to 3SF. PT is approximately equal to 10.1 kilometers. Roman figure 2, the height of the control tower is QR equal to TS. But QR is equal to PRO minus PQ. We can obtain PRO by considering triangle PROT. That is PRO. Then we can obtain PQ by considering triangle PQS. So that when you subtract both, you have the required height of the tower. In triangle PROT, P-R-T, we have opposite adjacent. That is tan 33 degrees equal to PR over RT. You have it in this form. Multiply through by 8.5 to clear fraction. You have PR equal to 8.5 times tan 33 degrees. You have this result and this result. In triangle PQS, QS is equal to RT, 8.5 kilometers. We are considering this angle. Here is opposite and here is adjacent. So tan 30 degrees is equal to PQ over QS. You have it in this form. Multiply through by 8.5 to clear fraction, and you have PQ to be 4.9079. Hence, QR, height of the control tower, is equal to 5.5199 minus 4.9079, and that is 0.612 kilometers to 3SF. If you convert this to meters, multiply it by 100, QR is approximately equal to 612 meters, since height is measured in meters and not kilometers. You convert it to meters by using 1000 to multiply this. 1 kilometer is equal to 1000 meters. To convert this to meters, you multiply it by 1000. Example 9. A control tower and a building stand on the same horizontal level. From the point at the bottom of the building, the angle of elevation of the top T of the tower is 65 degrees. From the top Q of the building, the angle of elevation of the point T is 25 degrees. If the building is 20 meters high, calculate a part of the question, the distance PT, B, hence or otherwise, calculate the height of the tower. Give your answers correct to 3SF. Solution. Considering all we have done so far in the previous examples and explanations, this diagram represents the information. TS is the tower, PQ is the building. The question says that top of the tower is T, top of the building is Q. So from the bottom of the building to the top of the tower, the angle of elevation is 65 degrees. From the top of the building to the top of the tower, the angle of elevation is 25 degrees. The height of the building is 20 meters. We have to find the distance PT. We have two triangles here, but we cannot use triangle PST to get PT because TS is unknown, PS is also unknown, but we can use triangle PQT, and that must be sine rule. So we need this entire angle, that is 25 degrees plus 90 degrees, the angle facing PT. So we have to get this angle in order to use it with the given side. From the triangle we are considering, the sine rule is stated in this form. But all the angles are not completely given. I mentioned this earlier. So let's start with angle Q. That is angle PQT. The sum of these two angles, and that is 115 degrees. For us to get angle QTP, this angle, you come here, you get this angle by looking at triangle PST. You get this entire angle by looking at triangle QRT. When you subtract both, you get this remaining angle. So in triangle PST, you add 90 degrees to 65 degrees and subtract the sum from 180 in order to get this angle, and that is what you have here. The result is 25 degrees. To get this entire angle, you add 90 degrees to 25 degrees, subtract the sum from 180 degrees. You have the result to be 65 degrees. To get this angle, it becomes 65 degrees minus 25 degrees, and that is 40 degrees. We cannot proceed with the sine rule. So from the sine rule, you replace the known side except PT. If you cross multiply and divide both sides by sine 40 degrees, you have PT equal to this. You have this result and this result. After division, PT is equal to 28.1985. To 3SF, PT is approximately equal to 28.2 meters. B part of the question, the height of the tower is TS, and that is considering triangle PST. That is the second triangle P. This point is S, here is T. TS is the height of the tower. Now that we know PT and this angle here is 65 degrees, you have opposite hypotenuse that must be sine. So sine 65 degrees equal to TS over PT. You have it in this form. Multiply through by 28.2 to clear fraction. You have this result and this result. Finally, TS becomes 25.55766. To 3SF, TS, the height of the tower, becomes 25.6 meters. Example 10. The angle of elevation of the top of a flagpole from a point on the level ground is 30 degrees. From another point on the ground level 20 meters nearer to the flagpole, the angle of elevation is 60 degrees. Calculate the height of the flagpole. Solution: the flagpole is AC. This is the first point whose angle of elevation is 30 degrees. We have another point nearer to the flag. That point is T. The angle of elevation of that point is 60 degrees, and that point is nearer to the flag by 20 meters. So let's label BT as S. The entire length becomes S plus 20. From the given question, since TC is known, we don't have to put ourselves looking for S. Just consider triangle ACT. ACT. And that is tan 60 degrees equal to AC over TC. That is height over 20. Height becomes 20 times tan 60 degrees, and that is 20 root 3 meters. Under special angles, the value of tan 60 degrees is equal to root 3. Assuming this part is unknown, then you have to use the information in the two triangles in one triangle. But since TC is known, you go ahead. If you check the example on two canoes, is something like this, but this part is unknown. We have to use the information in the two triangles in one. Example 11. In the above diagram, AT represents the height of a building 5 meters high, which stands 20 meters away from the foot of a pole BS 13 meters high on the same horizontal. Calculate the A part of the equation. Length AB to 3SF. B, angle of elevation of B from A. C, angle of depression of base T from B. Diagram, we need to adjust it. We have to close this part. We have somewhere here, because the base T is mentioned, we have angle of elevation and depression. Then we have the complete solution. The given diagram is adjusted to this form. First, we close this part because it is equal to TS from the top of the building to the top of the pole, then from the base to the top of the pole. From the eye level to the top of the building, the angle of depression is theta, which is equal to this angle. From the top of the pole to the base of the building, we also join it together. The angle of depression is alpha, which is equal to this part. The height of the building is 5 meters. TA is equal to SC, 5 meters as well. The height of the pole is 13 meters. If 5 meters is already out of it, the remaining part must be 8 meters. A part of the question, length AB is by Pythagoras rule, since triangle ACB is right angled triangle. Here is 90 degrees. You have this side, you have this side. The longest side is unknown, that is AB. The rule states that the square on the longest side is equal to sum of squares on the other two sides. AC is equal to TS, that is 20 meters. So you have 8 squared plus 20 squared, that is 64 plus 400, 464. To get AB, you take the square root of both sides. AB becomes 21.540659. To 3SF, AB is approximately equal to 21.5 meters. B part of the question, angle of elevation of B from A. B from A, you go to A and the angle is theta. Here is 8, here is 20. That is opposite adjacent. We have tan theta equal to BC over AC. You have it in this form. To get theta, take the inverse of tangent of both sides, and that is 11.31 degrees. C part of the question, angle of depression of base T from B. Angle of depression of base T from B. This is, so you go to B and get that angle, but we can only get it from here. We can get it from here, and it is equal to this one. So we have the required angle, everything here is opposite, TS is adjacent, so you have tan alpha equal to BS over TS, and that is 13 over 20. You have 0.65. To get alpha, take the inverse of tangent of both sides, and you have 33.02 degrees. Angle of depression of base T from B, you go to B, but we cannot obtain alpha from this side. It has to be from the side of elevation because it is equal to the angle of depression. End of lesson 4. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. If you are not safe, your life is in crisis, your life is in trouble. To avoid that, you have to give your life to the Lord Jesus Christ and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations, live righteously and be prepared, because on the last day, some will be taken and some will be left. Be good to yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.